Hello guys, in this tutorial I will give you a brief introduction how to use a neural network in Root. So first I will give you an introduction, then I will go through an example, then tell you how to use the tool and class that provided by CERN Root. Okay, let's get started. So the first introduction. Actually, this is the website I really recommend to take the first step to understand this multi-layer perceptron class. Okay, so I think this is the author's website who wrote this class. So basically, what the neural network is kind of a similar structure of how our neuron in our brain. So it looked like this pattern here. By the way, if you want to have a more general introduction, I recommend this website here. It is very straightforward and very clean to see here. I also list the link here. So you can think about this is you have some input and you have some output, and the relationship is pretty complicated. And it may be very difficult to find a model like you can fit the function. It's really hard to find a function to fit that. So instead of finding analytically a function to fit it, we can think about to have a lot of data, and then we can use the try and error like to build a model. You can say, okay, this data work if that something parameter is there. You give a lot of data, and then you train the network with a lot of time. So the network kind of remembers some parameter. So that then next time you put an input, you will get the right output. Yeah, this works magically. Okay. So what the neural network can do, basically in the physics, you can do like classification. Something you can think about. You want to know this signal is background or is useful signal or just a background noise. Okay. Or sometimes you want to do the fitting here. And in this tutorial, I'm going to show you how to do the fitting. So I would demonstrate this example here. Okay, so you see this is a pretty difficult to find an analytic function to fit the data here, and this is the output of your neural network, or we call it artificial neural network ANN here. So I think this is a kind of introduction part here, and how and you probably kind of get some sense of how it look like. So you can think about it's just similar to the linear algebra. Okay, you have an input kind of 3, now you have vector of 3 element, and you have a vector of output layer 3, and you can think about this is a transformation from this point to a hidden layer. You can think about it's a vector, different vector, so you have a matrix. So we call the matrix kind of weight matrices, like because this neuron will take all of the input from this all the input from each input layer here. You see this also take all this, and it take different weight. Then you kind of linear algebra to sum over this. So our job is to let the system to know the weight, so that every time you put the value, input value, you get the right output value here. But the thing is not always that easy. Okay, so you can have multiple hidden layer, and also the output here is not just the same output. I would tell you what it look like. It's called sigmoid function. Okay, so you have linear algebra of that input. Here I just hand waving. I don't want to spend too much time. Then you got the output from another function here. Okay, I know this sounds very vague for the first time, but you will have a more solid idea what would happen there. Okay, so let's go to let's take a look at an example here. So so this sample would be feeding a field. Okay, so the data is from, I believe it's from here, the magnetic field of the radical component. So so the input we actually we have here. This is our data set here. So think about the first row. Sorry, the first column here is, and the second column are the coordinate. So it's in a cylindrical coordinate. You have R and Z here, and your output is like the magnetic field of radical component. So you can think about this is X and Y axis, just your true input, and your Z coordinate is your output here. Okay, so but remember, sometimes we have to do normalization for either input and output. In a root, it would automatically help you to handle input normalization, but sometimes we need to output normalization. So for what I mean is, you take a look at the scale here. This is the original. It go to 20,000, you see here, but the output is just 5 here. So it's very different. But the shape is looking okay, but the scale is different. So you have to normalize the output here to match your neural network output here. That's what I mean. Okay, so we want to do the fitting here. So in this case, you have kind of different output value, kind of a range. So in case of classification like this, you just have two kind of possibility. You either 1 or 0. Okay, so 1 could be representable signal, 0 is background. That's easier, and this case has a multiple value. Okay, so here for doing a neural network analysis, basically the fitting process is kind of trivial, but the thing is you need to find the data set to fit it in to your network. So the data is more important. I mean, sometimes you need to find it on the right data set here. So I prepared a class that I just wrote. It's very simple. It's take in the data from Br.dat, this file, and you have R, branch code R, and branch code Z, and branch code VR here, and that will use as our input. Okay, kind of a true data that can fit into this neural network. Okay, so let's start it. Okay, so this script called demo.demo underscore ANN here. So this is the entrance. Okay, so step 1, we need to prepare the data that's feeding into our network. So here is here I use a tree. Actually, you can use a tuple class. That's okay. So anyway, I get a tree, and this tree has this branch R, Z, and BR, and they come from this file here. Okay, pretty easy and straightforward. No big different concept. So then we set up and train our network. Actually, it's pretty easy. Just 3 pieces of code, 1, 2, and 3, and you done. Okay. Actually, sometimes you can skip this middle line here. Let me explain what that means. Okay. So first of all, we create an object from a TMultiLayerPerceptron class here, and this is our main object to do the artificial neural network. So in this part here, this is a constructor that takes in a lot of things here. So first of all, you need to specify the structure of your network. Okay, so in this case, because I have two inputs, so I put R and Z here. I put the at symbol here. That means I want to normalize the input. Okay, you make some normalization, and also I want to normalize the output here. Normalization is very important. Sometimes if you don't put this sign here, the X sign, sometimes it won't work. Okay, so you have comma to separate your input or output here. In this case, I just have one output here. Then use this column here to be a layer. Okay, so I make it quite fancy. I use 3 hidden layer, and each hidden layer has 10 neurons. Okay, so you can put as many as you want, but remember to put more, that means your calculation time is definitely longer. And sometimes you just want to your system is simple. You don't need to really read a lot of neurons to do that calculation. Okay, so the T here is the tree object. Okay, so we put it here, and inside this tree we have branch R, Z, and BR. Okay, so the name here corresponding to the branch name in this tree here. Then we kind of strange thing here. This the entry $sign %2. That means that the entry number equal to even when it's true, you will be testing data set. And when it's odd, entry number is odd, it would be the training and testing data set. Okay, so there are two data sets here. You can even don't put this part here. You will be by default use even and odd. So remember, we need to train the data and testing our result. So that the total error or total deviation from our input is as small as possible. Okay, so sometimes we will have bias when we put in the training data, so we need the testing data to avoid this bias. Okay, this is kind of a very deep concept. I don't know quite much, so I will skip this here. Anyway, you know, the first argument is for the structure, then the data, then how much you want to distribute to the training, how much to distribute to the testing. Okay, you can use the 1/3 and 2/3. That's okay, but it's 1 by 1. It's pretty much okay. So this is the first thing, pretty important to set up the structure. Now you set a learning method. Okay, so the default is this one here. Actually, if you want to just use default, you actually don't need this block here. As I said, you want to have parameters like transformation or the matrices. There's a weight here. So how this what does this learning do is to according to a deviation, so you adjust it a little bit. So this is the learning method is different algorithm to update the weight here. Okay, so sometimes you can try different one, but the default one works pretty well. Okay, so then the coming to the exciting part, you want to train your data set. So in this file here we have 720 20 data set, because the first two are just a command here, and we want to run its iteration 5,000 times, but typically it's too much. Why? Because you will see the error kind of converge or going down, and certain it becomes stable. So if you just running too much, you're just wasting your time. But for demonstration, I use Python. You can see what would happen. So you can have either update showing in a text format or graph format, and that's in the period of 100. So 100 iteration, it will show an update for you. You can check the arrow that show how it's progress. Okay, so far we set up all the things we need to do the network analysis. So next thing is to use it. Okay, so this part here just taking some data set from the Br.dat is straightforward, so I skip it. Okay, so we will use it a little bit later. So to use it very easy. So Br understood the cal. This is a calculated Br. Here we use MLP. This is an object from our multi-layer perceptron, and code the method evaluate. This zero is index zero is always there. You just put it here. So you have two input. You put a array of two items here. One is your R and Z here, and then you got the result. Okay, it's pretty straightforward. So we will use a graph object to put that thing in the canvas. We divide by the canvas. First one is just using the data from the Br.dat here, and another one is the calculation result and put it in the second pad here. Okay, let's take a look. It's very similar to what you will see here, but let's run the code. Root demo, and I see. Okay, doing. So you will see here, you will total 360 training and 360 for testing. So it's one by one. So you can see the epoch. So kind of iteration. So you see the first arrow is look like that. So it will going smaller and smaller and reach some point kind of more like stated and not change too much. So you know this is a kind of limit you can get. Okay, so we will wait a little bit until it goes to the 5,000. All right, so I just so let's take a look for first one here. Oh, this is our result here. This is the first pad, second pad. So this is our data, and this is our neural network result. So you can see it's very similar, except this part a little bit weird, a little bit, you know, kind of more deeper. Okay, but in general it's pretty good. You see. Okay, so then my job is to explain what is this here. Okay, so then I will show you what is the multi-layer perceptron analyzer class. Okay, so this panel here is kind of a property check, show you how good the network is, or which variable would affect the network more. So let's take a look first. Okay, so to use the MLPAnalyzer is very easy. So you declare a class from MLPAnalyzer, and you put your network object, MLP object, in a constructor here, then you're done. Okay, so in the first thing you need to do is to the initialization. You have to put this method here, gather informations. Okay, then then you can put a check network. It will print something on the console. So I think is here. Okay, so this all the thing is printed out here, this block here. So it show you it's okay. The result pretty nice. No worry. Okay, no strange mesh. So we go to the pad here for the first pad here. This is the draw inputs this method. Okay, this is a little bit tricky to understand at first time, but let me show you how to interpret this graph here. So you see these two different distribution here. So one is for R is in the black color, and one is for Z in the red color here. So what is showing here is the x-axis kind of derivative of that event. So think about this. Kind of changing how is if you go to this bigger X, that means your change is more severely with that event. So normally you want that your network is very stable. So you want a lot of accounts towards a very low change. So if you see here, you see that's a good sign. Most of the accounts, most of the event that's just slightly change the network here. And also you can find the red curve, a red distribution has a further impact on the network because it has some larger slope or larger derivative here. Instead, the black, the Z, change smaller here. Okay, and then we go to the second pad here. This is just showing the structure. Okay, so we have two input, 3 hidden layer, and each hidden layer is 10 neurons. And you can see this is the weight, the line thickness represents the weight of the each transformation matrices or weight matrices. Okay, so this is pretty interesting. You can draw. It can play all the day. Okay. Anyway, so it's just use your multi-layer perceptron object to use the draw method. You show very beautiful class. So then I have the third pad and fourth pad. What that mean is the kind of deviation. The deviation, this is the output minus the real or true data set. The x-axis is the VR. So that's mean if your VR go up and up and up, what's the difference between the calculation and original data set? In this case, I normalize the original original VR here. I normalized here, such that you can have similar scale. So if you follow the example from the web, you can see this is pretty different. So you will not see the really small difference here. Okay, so just tell you there is something different in my code here. So you can see this is output and how it changed with the arrow here. So this is a T profile plot here, and this plot with the arrow here. So this is the third one, and then the fourth one is the draw true derivative deviation in outs. Okay, this is a pretty mouthful. Okay, what is mean is same here. The y-axis is the difference, and the x-axis is corresponding to your input here. So you can see your different input value and the difference. Okay, so you can see actually the red one cause much difference So you can see it here. So this part just showing you how to examine that your results to see how good your network is. So finally, you can write out to file by this export. You can have C++ format or Python format. So later on, you don't need to train your network system again. You just input the class. Let me show you what it look like. So supposedly we should have my an.css, cxs, or my an.h. So let's try the my an.py first, because it's just one file. It's easy to explain. Okay, so if you use Python, you will first know this is a class and a lot of function in it here. So in this, you have to put index 0. Where are we? Okay, so that means well, sorry. Okay, here. So this line here. All right. So index 0 and inputs. Okay. So put index always 0. Otherwise, it do nothing. Okay, 0 and to input here, and you will get the output from this function here. So let's take a look at this function. So you will have a lot of a function coming in and different weight. Okay, so that means you want to get this, and you have a lot of things to fit into it. So let's take this guy here. So you can see this is a weight, and then go to another functions. Okay, and go to another neurons. Okay, and this is a weight. Let's try a little bit here. So you go to the neuron here. So you see here, you return 1 divided by 1 plus exponential and minus input here. So this is what I call the sigmoid function here. The output is kind of a sigmoid function output. Okay, so next time if you want to use it, you just to declare this class and object and use it. And it's very similar in a C++ version. Okay, so for just very quick check, we can take a look. Okay, so your header file is here. It's very similar. You just put into 0 to input or put an array in it, and you will get your evaluation value. So that's basically the use of the neural network. And sometimes you need to try several times to find out the right setting. I mean, how many hidden layer you want to use, and what kind of training method is good, and what is the generation you need. Okay, and most